I'll do these last three problems all in one go, as they're all pretty similar and should be pretty easy to set up. So I'll spend a lot of time on question 14, and the other two should be pretty straightforward. It says, find the minimum distance from the line y equals 2x plus 3 to the point 1, 0. So from this point, I can extend this line as far as I want either way. Okay, this distance is really long, this distance is shorter, this distance is shorter, shorter, shorter. Probably get to a minimum distance, and then we start getting longer again. Okay, so I should be able to make some sort of function that will tell me how long this line is based on some variable. Okay, the way we're going to do this is consider the coordinates of just some random point. I'll put the point here. Yeah, okay, there I'll do. The coordinates of this point. So I'm going to make the x coordinate just x, and instead of having the y coordinate as y, I'm going to have this coordinate as 2x plus 3. Okay, I've subbed x into 2x plus 3 and got 2x plus 3. The coordinates of this point are x, 2x plus 3. Okay, I'm going to find an expression for the distance between this generic point on the line and 1, 0. I'll make this a little bit bigger. I really have a right angled triangle here. Okay, I'm trying to find this hypotenuse C. This distance here is 1 minus x. This distance here will be 2x minus 3 minus 0, or just 2x minus 3. The diagram's starting to get a little bit messy, but essentially I have a triangle. Instead of letting this be C, I'll let it be D. Okay, let D be the distance. Between the line and a point. So that nasty diagram that I have is really 1 minus x, 2x minus 3, and I'm trying to find D here. Okay, so I'm going to be using Pythagoras Theorem. There is a distance formula, if you remember from year 10. Distance is change in x all squared plus change in y all squared. So you could do the same thing with these 2 points. Okay, point 1, point 2. And just apply distance formula like x2 minus x1 all squared, y2 minus y1 all squared. Okay, but we don't need that. We can just use this little triangle that we've created. Okay, I know my Pythagoras relationship will be d squared equals 2x minus 3 squared plus 1 minus x squared. So the distance between the 2 points will just be the square root of this. Okay, and before I differentiate, I'll probably expand it and make it look nice and neat. Okay, 4x squared minus 12x plus 9, and then expand this next one, plus 1 minus 2x plus x squared. Okay, collect like terms. 5x squared minus 14x plus 10. Okay, and then I can differentiate this and find whereabouts. So I'll differentiate it. I'll find an x value where d dash of x equals 0, and that'll tell me on my diagram where along this x-axis I should be, which will tell me what point I essentially should be on there, and I can sub in that x value to find the distance that'll be the minimum distance. Okay, essentially we're going to end up with this answer, okay, since we've drawn the diagram. Okay, in reality you don't need to draw the diagram at all, as we'll see in one of these next examples. Okay, question 15, find the minimum distance from the parabola y equals x squared to the point 5, 0. Okay, again, choose some random point on here. It has coordinates x and x squared. Okay, x and y, or x squared. I want to find the distance between these 2 points. Right angle triangle. This distance is 5 minus x. This distance is x squared. Okay, again, let d be the distance. I've got 5 minus x and x squared and d up here. Okay, write my so by Pythagoras x squared plus 5 minus x squared equals d squared. Probably wanted to really write that the other way around, so I've got d on the right hand side just so I don't scare anyone. So d is square root of x squared squared, which is x to the power 4, plus 5 minus x all squared. And we can do some, we'll do some expansion. X to the power 4 plus 25 minus 10x plus x squared. And we'll just put these in ascending order. Sorry, descending order. Okay, so you'll differentiate, find where d dash of x equals 0, and then use that to find the minimum distance. One last problem, question 16. A comet is following a path in the same plane as Mars according to the rule y equals a half x squared minus 4, where Mars is the origin and xy are in millions of kilometers. Alright, I might just draw a brief sketch of what this probably looks like. Half x squared minus 4 means the y-axis intercept is minus 4. A half is a positive a value. So it'll look something like this. Okay, with our sketches we don't need to be particularly accurate. We want to put a point here and find what's the closest distance the comet gets to Mars. So I've got Mars in the origin, comet going around like this. I want to find what's the closest distance. I'm going to use, again, just some generic point. Okay, some random point here, x, and instead of writing y, I'll have a half x squared minus 4. So the coordinates of this point are x, half x squared minus 4. I want to find the distance between the origin 0, 0 and that point. Okay. Again, right angle triangle. This distance is x, this distance is a half x squared minus 4. So I can draw my right angle triangle here. Again, let d be the distance. We've got x here. And a half x squared minus 4. There's d. Okay, again by Pythagoras d squared is x squared plus a half x squared minus 4 all squared. So the difficulty here is just doing this second expansion, probably where most people mess it up, which is why it's a modelling question. I'll do the expansion before I take the square root. So a half x squared all squared will be a quarter x to the power 4. And then I'll minus 2 lots of half x squared times 4, so 2 lots of 2x squared, 4x squared, and then I've got a plus 16 at the end. You can do the FOIL expansion if you're not comfortable doing that. Collect some like terms, so I've only got one x to the power 4 term, I've got minus 3 x squareds, and a 16. So I can now write my distance function a quarter x to the power 4 minus 3x squared plus 16. Okay, this is the thing that you need to optimize. Thinking back on those 3 problems I did, I'd probably change this to be a capital D instead, just so that I can, if I wanted to, I could use the dd dx notation. Okay, I can't really do dd dx with lowercase, it doesn't really make sense.